Divisibility rules. We're going to focus on these rules right here. The rules for 2s, 3s, 4s, 5s, 6s, 9s, and 10s. Now, your first test talks about 7s and 8s. Don't worry about 7s and 8s. So don't do the 7s and 8s. Okay? All right. How do we know if a number is divisible by 2? All numbers that are what are divisible by 2?
Even.
Even. So how do you know if a number is even? It ends with what?
2, 4, 6, 8, 10.
Okay, you're very close. 2, 4, 6, 8, or
10.
0. Good. Now, is 0 even? Just the number 0. Is it even?
Yeah.
No, it's neither. Okay. So any number that ends in 2, 4, 6, 8, or 10, or not 10, excuse me, 0 is even. So is 20 even?
Yeah.
30?
Yeah.
Yes. Does that make sense? All right. So, all even numbers. Okay, someone give me a 4-digit number that is divisible by 2. Give me a 4, so in the thousands. Raise your hand. Hey.
2,222.
Okay, that works. 2,222. Someone give me another 4-digit number that is divisible by 2. You cannot use the number 2. Peyton. 9,998. Yes, one more. Abigail. 1,864. So even though those numbers are really big, they are divisible by 2 because they end with an even number. Any questions on the 2's rule? Okay, the 3's rule is very similar to the 9's rule. It's a cool rule. This is the rule that I like the most and I think helps the most. And it says that you add, oops, that was my second word, add all digits. Guys, gotta move. I'm not doing it anymore. Go back to your seat, and Peyton, go sit back there by Mr. Harper. Okay? You cannot sit by each other when you come in my classroom right now. Alright, add all digits. If sum, what's a sum? Josh?
Like an answer to an addition.
Good, an answer to an addition problem. If the sum is divisible by 3, then so is the number. Okay, very simple. Someone give me a 4-digit number. Any 4-digit number. Okay, use different digits just to mix it up. Braden.
5,723.
5,723. So let's follow this rule to see if this is divisible by 3. Does it end in a 3? Yes, that doesn't matter. Add all the digits. So let's add them. 5 plus 7. 12 plus 2.
14.
Plus 3. 17. Is 17 divisible by 3? No, then neither is this number. Someone give me a 4-digit number that would be divisible by 3. So the digits have to add up to a multiple of 3. There we go.
5,724.
5,724. 5 plus 7 is 12. Plus 2 is 14. Plus 4, 18. Is 18 divisible by 3?
Yes.
Yes, it is. So then so is this number. Okay, it's very simple. Okay, someone give me a 5-digit number that's divisible by 3. Just start off. Let's go. The best way to do this is just start saying numbers. What do you want?
It doesn't really matter about the 2. 7.
7.
3.
So 73,000. That adds up to 10.
738.
738. Let's try it. 7 plus 3? 7 plus 3? So we have 20 plus 8. Is 28 divisible by 3?
No.
No. So what do we need to change this last number to? We have 20 so far. Give me a number here that would make it divisible by 3.
6.
That'd be 26. Is 26 divisible by 3? So we have 20 plus what? 4. I have 10, 20, 24. Is 24 divisible by 3?
Yeah.
Then so is this number. What else could I put here rather than 4?
1.
I could put a 1. Is 21 divisible by 3? Yes, I could. What else could I put here? I have 1, 4, and count by 3s. 1, 4, and
7.
7, because 27 is 27 divisible by 3.
Yes.
Yes, 9 goes into it. Do you see how that rule works?
It's
Okay, you'll practice it. Trust me, you'll get it. Add the digits. If that sum is divisible by 3, so is the number. Now, the 9's rule is exactly the same. You add all the digits, but it has to be divisible by what?
9.
By 9. That's the difference. Okay? Add all digits. So I'm going to say, but it has to be divisible by, so I'm going to put dots. All right, dots. That means that that's that. Must be divisible by 9. And I should actually say that the sum. Sum must be divisible by 9. So these are dots saying that. That's up there, okay? Does that make sense? So let's go back to this digit right here. We have 7 plus 3 is 10, plus 7 plus 3 is 20, and I have a 7. Is 27 divisible by 9?
Yes.
Yes. 27 is divisible by 9. What if I went back to my 4? Is 24 divisible by 9?
No.
No, we had a 1. Is 21 divisible by 9?
No.
So are there going to be more numbers divisible by 3 or by 9?
3.
By 3, it's smaller, right? Okay, good. All right, 4s, very simple. The last 2 digits.
So, wait.
Must be divisible by 4. I'll give you an example. 816. Look at my last 2 digits. What's that number right here?
16.
16. Is 16 divisible by 4?
Yes.
Yes, it is. Okay, I'll make it a little harder. 9,348.
8. Yes. Yes.
Is 48 divisible by 4?
No.
Yes.
Oh, sorry.
Okay, hold on.
Yes.
Raise your hand. 4 times what equals 48?
12.
12. Okay? Now, once you get past 48, it gets a little more challenging, though, because we're used to our facts up to 12. Once you get past 48, you're going to have to do a little more thinking. But one thing I do want to throw at you here is that anytime you have, like, 100, my last 2 digits are double zeros. Do you see that? Anytime you have double zeros at the end, it is divisible by 4, because is 100 divisible by 4? How many quarters are in a dollar?
Oh.
4 times 25.
Oh.
Okay. How about 200?
Yes.
4 times what equals 200? 50. Do you see my point?
Yeah.
Anytime you have double zero, no matter, I could put anything I want here. I could put
Zillion.
4,000. It's double zero. It's divisible by 4. Okay, 5 is very simple. You should already know this rule. What's it have to end in to be divisible by 5?
5.
A 5 or a?
Even number. I mean, odd number.
Shh, don't just say stuff. Think. Must end with
5.
5 or. Think of all the numbers that are divisible by 5. 5, 10, 15, 20, 25, 30. What do they all end in? 5 or 5 or 0.
67, 80, 90.
Okay, 6s. The only rule for 6s is that 2 and 3 must work. So rule 2 and 3 must work. So if something is divisible by 2 and by 3, it is also divisible by 6. I'm going to test you with that. Think of the number 18. Does 2 go into 18?
Yes.
Does 3 go into 18?
Yes.
Does 6 go into 18?
Yes.
Yes. Think of the number 14. Does 2 go into 14?
Yes.
Does 3 go into 14?
No.
Does 6 go into 14? No, you see? Pretty basic. How about 30? Does 2 go into 30?
Yes.
Does 3 go into 30?
Yes.
So does 6.
No.
If 2 and 3 work, so does
Oh.
6.
Oh, I get it.
And 6 times 5 equals 30. Okay, I'll give you a different one. How about 33? Does 2 go into 33?
No.
Does 3 go into 33?
Yes.
Yes, but with 6.
No.
No, because 2 and 3 have to work. Does that make sense? Okay, good. All right, 9s we already talked about. You add all the digits. The sum must be divisible by 9. 10s, very simple. 10, 20, 30, 40. What's it end with?
Zeros.
Must end with 0.
Well, that's easy.
All right. Okay, that pretty much ends the little mini lesson here. And so what you're going to do, you can go ahead and shut off now.